Hey guys, welcome to the next video on OpenCV tutorials for beginners using Python. In the last video, we have started our simple project of detecting lane lines on the road using OpenCV. And we came to the point where we were able to define our region of interest, and our result was looking like this. So let me run this project. So we have defined this region of interest, and now the only thing which remains here is to detect these lane lines. So we will once again go to the next step, and the next step will be to find out the edges, and then we are going to apply Hough line transform to draw the lines. So first thing first, what I'm going to do is I'm going to just move this region of interest function which we have created in the last video on the top of this script, so we can see this other code clearly, this code which we have written. So we have this region of interest function which we have created, then we have just created this region of interest variable, and then we just used our region of interest function using this region of interest vertices variable. So the next step, as I said, is to find out the edges, and for that we need to first convert our image into a grayscale image. So I'm going to just say a gray image, and then we all know how to find out the gray scale image out of an image. So we just need to write CVT color, and the source is our cropped image. So we are going to pass our cropped image, and then we are going to just convert it into a grayscale image using cv2 dot color underscore RGB to gray. So let's do this. So once we got our grayscale image, we can apply Canny edge detection on this image. So I'm going to just write Canny image, and then I'm going to just say cv2 dot Canny, which is the function which we want to use, which takes few parameter. First parameter will be our grayscale image. The second parameter will be the first threshold and the second threshold. So generally we are going to take here 100 as the first threshold and 200 as the second threshold. Now in the next step, we are going to just display this image on our matplotlib window, and let's see what happens once we apply this Canny edge detection method on the image. So now you can see this result which detects all the edges, and here you can see the lane line edges are detected, but there is one more thing here, which is the edges of our region of interest are also detected. So how to solve this, how to remove these edges, because these edges doesn't interest us. The interesting edges here in this image for us are these edges which are of the lanes, road lanes, right? So to solve this problem, we can apply this Canny edge detection before we find out the region of interest. So I'm going to just copy this code and paste it just before we apply this region of interest method which we have created in the last video. So now in our Canny edge detection, we will pass the grayscale image, but here instead of this cropped image which we were getting in the last step from this variable, we directly are going to pass our image which we have read using the IamRead method, right? So let me just remove all these line breaks so you will be able to see the code at once. So here you can see I have directly passed now this image variable to the CVT color method. So we get the grayscale image of the original image, and then we apply the Canny edge detection on the original image, and then we are applying the region of interest method which we have created in the last video. Now because we are applying this region of interest method on the grayscale image or the edge detected image. Therefore, we don't need this channel here. So we can comment out this code, which was counting out the number of channels, and for the grayscale image and the Canny edge detected image, we just take this match mask color as 255 because it's only one color, right? We don't need any color channels here because we are just passing the grayscale image which has only one color. So that's why we don't need any channel, because there will be only one channel, and that's why I have commented this code, and the value of the match mask color will be 255 now. Once you do that, let's try to run this code and let's see what happens. Once again, we need to load the cropped image, not the Canny image. So just replace this variable here in the IAmShow method, and let's run this code once again. So you can see now there is some mistake here because we were expecting the edge detected image and we are getting this image. So let's see what's the problem is. So the problem I see here is because we have applied this region of interest on the original image, which we don't want now. We want to apply this region of interest on the Canny edge detected image. So we have to pass as the first variable of the region of interest method this Canny edge detected image, not the original image, right? So once again, for you can see this code, region of interest method, and all this code at one glance. Let's run the code and let's see what happens. So now we get the better result. So we have these edges which are detected by the Canny edge detection for only the lane lines inside our region of interest, and now it will be easier to draw the lines on these edges which we have detected. So the next step will be to draw the lines on these edges using the Hough line transform. So we have in the previous videos have already seen how to use the Hough line transform. So I'm not going to go into the details. So let's just directly jump into using that Hough line transform. So what we are going to do is, in the next line, after we have got our cropped image, we are going to just define a variable called lines, and we are going to use this Hough line transform, probabilistic Hough line transform method. So here cv2 dot Hough line transform, and this will be this method which takes few arguments. First argument will be the image, so I'm going to pass this cropped image here. The second argument here will be the value of row. So let's provide this row variable value, which will be 6 in our case. Then in the next parameter we have to pass the value of theta, and theta will be equal to np dot pi, which is the method inside the numpy library. So np dot pi divided by 60. So I'm going to pass here divided by 60. Then the next parameter here will be the threshold. So the threshold value we are going to provide here will be 160. The next parameter here will be lines, which is equal to none by default. So I'm going to provide this variable lines is equal to, and then we are going to pass the empty numpy array. So I'm going to just say numpy np dot array, and then we are going to just pass the blank square bracket here. The next two parameters will be the min line length. So let's provide this min line length, and let's say we want 40 as the minimum line length, and the max line gap. So let's provide that also, max line gap, and this will be let's say initial value for that will be 25. So now after applying this Hough line transform, you know that it's going to return the line vector of all the lines which are detected inside our image, which we have provided as the source here. So if you don't know what are these parameters which I'm using here, you can see my last videos about probabilistic Hough line transform, and you will be able to know what they actually mean. Now once we got our line vectors, then we can draw the lines easily, and for that we are going to define our next function, which is to draw the lines. So I'm going to just define this function with the name draw the lines, for example, and it's going to take few parameters. So let's pass these parameters. First parameter will be the image, or the original image. The second parameter will be the line vectors which we have found out, and that's it. So there are these two parameters we are going to pass here. Now inside this function, what we are going to do is we are going to first of all copy our image. So I'm going to just say img is equal to np dot copy, and then we are going to just make a copy of the image variable which we are providing, and then, or you can write here copy image whatever. I'm just reassigning this copied image to the same variable, but you can define a new variable here for the copied image also. Now in the next line, we are going to create a blank image that matches the original image size. So the dimension should be equal. So for this we can just say line image, and then we are going to just say np dot zeros. Inside these parentheses we are going to provide the shape of our image, right? So you can provide the shape of our image using the image variable. So first of all, it's going to take the height, and then the width, and then the number of channels. So because we know that this is a colored image which we are working with, so we are going to just say img dot shape, and we all know that the 0th index parameter here will be the height. The second parameter img dot shape, the value at the first index will be the width, and the number of channels for the colored image are always 3. So we are going to provide the third parameter as 3 here. So this is in the form of tuple I'm providing, and the next parameter here will be the data type or d type. So let's provide that. D type is equal to numpy dot uint 8. Okay, so uint 8, not unint 8, uint 8. So this will be the second parameter. So once we have this image which is exactly same as the size of our original image, we are going to loop around these line vectors, and then we are going to draw the lines, right? So let's loop around these line vectors and draw all these lines which were found. So for that we are going to use the for loop, and then we are going to say line in lines, and this lines variable is coming from this lines variable. So we are going to use this draw lines function, and we are going to pass this lines vector as the second parameter here. So this is how this line variable is coming here. So now inside this for loop we are going to just define one more for loop, because this line is going to give us 4 parameters, which is the coordinates of the first point in the line and the coordinates of the second point in the line. So we are going to just once again say for x1, which is the first coordinate of the first point, and the y1, and then similarly x2 and the y2. So this will be the line coordinate in the line which we got from the line vector. And then inside this for loop we are going to draw a line, and drawing line is really easy by using cv2.line method, which takes a few parameters, as you already know, the image, and then the second parameter is the coordinate of the first point, which we already have using this iteration, which is x1 comma y1, and third parameter here will be the coordinates of the second point, x2 comma y2, and then you can provide the color and thickness. So let's provide this color. So the color here I'm going to take, let's say 0 comma 255 comma 0. You can take any color here. And the thickness, so the thickness here I'm going to take is let's provide this parameter, thickness is equal to 3. Okay, so this is the thickness of the line which we want to draw, and here I think this blank image should be given, because we want to draw the line on the blank image and then merge it with the original image. So here we have to provide this line image, or you can say this is the blank image, which is more appropriate in this case. So we want to draw the line on the blank image, which is of the same size of the original image. And now once we draw these lines on the blank image, we can merge this blank image and the original image, which will give us the line which are drawn on the original image. So outside this for loop, we are going to merge the image with the lines into the original image. So our original image is the image itself. So image variable is our original image, and then we are going to just say cv2 dot add weighted. This function also we have seen in the last videos, and this is the function which we use to merge two images with some weights. So the first parameter here will be image. Now the second parameter here will be the value of alpha, so which we are going to give here 8. This is like a weight to an image which we want to provide. And then the third parameter here will be the second image. So we want to merge the blank image with the original image. The fourth parameter is the value of beta. So this value we are going to take as 1, and the last value will be of gamma. So gamma we are going to take as 0.0 here. Okay, so this add weighted also we have seen in the last video how to use it, so I'm not going into the details. And at last, once we have the lines on the image, then we are going to simply return it. So let's return this image img. So once we have this function, we are going to call this function after applying the Hough line transform method, which is the probabilistic Hough line transform. So here in the next line, we are going to just define a variable called image with lines, let's say, is equal to our method, which is draw the lines method. The first argument is the original image, so we are going to pass the original image. The second argument is the line vector which we got from this method, right? So the original image and the line vector variable which we got here. At last, we are going to just see what is the result which we got after applying this draw the lines method on the original image. So let's run this code and let's see what happens. So now you can see, let me just maximize it. You can see this line is drawn on our image. So this is the first line and this is the second line. So we got the result which we wanted. If you want to change the thickness or the color of this line on the image, you can just change it using this draw lines method. So this is the line and thickness parameter. So for example, I want to change this to 255 here, some different color, and the thickness, let's say 4, and I'm going to run this code, and now you can see this yellow color here, right? So you can change the thickness and the color using this method. So let's say for now we want the red color, so we are going to go with this red color on the lane lines. So this is what we wanted to achieve. We wanted to draw the lane lines on these lanes, and we have achieved this. In the next video, we are going to see how we can apply the same concept on a live video or on a video of this road, for example. So for example, this car is running on the road and we want to continuously draw these lines on the lane lines. How we can achieve this using OpenCV, we are going to see in the next video. So that's it for this video. I will see you in the next video.